All right, hey everyone, good morning. I'm Joshua Espinoso. I'm the CEO and one of the co-founders of Shift5. We do digital makeovers for weapon system platforms. So the founding team came out of about a decade of Army cyber experience helping to build Cyber Command, where we studied the cybersecurity properties of weapon systems. In 2018, a GAO report came out calling this out as one of our biggest national security crises. You might not think of something like an Abrams tank or a C-130 as a computer network, but it, regardless, has dozens or hundreds of electronic components on it that orchestrate everything from pilot input to moving flaps around, communicating over RF, GPS, what have you. And as we were looking at this pretty pervasive problem across weapon systems, we said, well, what do we do about this? And we looked to our cyber defense brothers and sisters in the cyber protection teams, and they looked at the giant stack of IT cybersecurity equipment that they had getting deployed out to go do incident response on weapon systems, and said, we got nothing. So we started thinking, well, why don't we add some things to these weapon systems? How could we create observability into these platforms so that if a warfighter calls us and says, hey, something really weird happened to a cluster of these aircraft and we think it might be a cyber kind of issue, can you come out and take a look? We actually have the tools and substrate to be able to answer some basic questions. And that's what led us to start Shift5 build this little box here. So this is a manifold. It's about the size of a Neil Stephenson paperback book. And this with a couple of wires connected to the right data buses on a weapon system allows you to teach old dogs new tricks. So you're going to hear a lot today from defense tech companies that are doing amazing things with new kinds of weapon systems, autonomy, AI, attritable drones, autonomous fleets. We love that. We also think we've spent trillions of dollars on a bunch of weapon systems that do a pretty darn good job. Arleigh Burke-class destroyers, F-22s, Stryker combat vehicles, and with a little bit of TLC and a 4-pound box, you can open these systems up to create, if not parity, pretty close to it, to the kinds of functions and features that we're seeing in all of these brand new builds of weapon systems. So obviously, cybersecurity very close to our knitting. We care a lot about weapon systems working when we ask them to do mission. But once you've got capable hardware and software installed onto a weapon system, and it has full understanding of everything going on the platform, it's listening to all the digital conversations, you've installed mission interfaces so that you can interact with the crews on those platforms. You've solved the comms paths. You've created kind of an operating system to be able to deploy all kinds of smarts onto those platforms. So you talk about cybersecurity, preventive predictive maintenance, JADC2, all that kind of great stuff. You open these platforms up to all the smart folks in this room and in the community to be able to build amazing software that can deploy on weapon systems. You're going to see one small example of us being able to do that on an aircraft that's been in service for several decades to be able to combat this menace that has been in the news recently called GPS spoofing. So with that, I'll hand it over to our head of product, Sam Raj.
Thanks, Josh. Perfect. So we're going to take you through the Shift5 platform in the context of a simulated flight here that's being flown right over there. But in this case, the mission that we're talking about is a NATO air policing mission on the border of Estonia and Russia. And essentially, we have a pilot who's flying their general course and general flight path as pre-planned as they go through to make sure that airspace is clear and safe. Now, alongside the flight path of the flight simulator here, we'll also bring up essentially a Google Earth view that shows the flight path that the aircraft is taking. And those two lines that you see there are both the GPS positional coordinates as well as the positional information as reported by the inertial reference units, which are also on the aircraft on a different bus. And these are positional information details that are collected in real time by the Shift5 manifold among all of the other data that's traversing the serial bus. And what you notice happening there that the Shift5 manifold is seeing is divergence between the positional information as reported by the GPS units and the positional information as reported by the inertial reference units. Now, some of this is predictable and some of this is bound to happen, and Shift5's analytic capabilities correct for that. But once the divergence reaches a certain amount of a point in time, Shift5 is able to, in real time or near real time, detect the anomaly and funnel that anomaly from this manifold to an in-cockpit electronic flight bag application such as ForeFlight, which a lot of pilots have up and running during the course of their flight, to show them that GPS spoofing, as an example of an anomaly, has been detected, so that they can then take any corrective actions, TTPs that they may have in place, to be able to move to a trusted source of positional information or fly VFR if they need to. In addition, Shift5's mission is how do we get the instances of these anomalies to the right people at the right time so that they can not only react quickly during mission, but support root cause analysis and post-mission investigation as well. And so what you see here is the same alert that was popped to the pilot onto the screen was streamed across a Starlink, as an example, or a radio antenna, any comms link that's already available on the weapons systems platform, to a ground station where a ground support team member, such as a mission defense team member or cyber protection team member, can get that information in context in near real time, understand that an event happened, understand where it happened, and start going through the context of what the aircraft saw at this point in time and work with supporting teams to understand whether this was a true anomaly, what caused it, and get to root cause. So all in all, just to summarize here, what you saw is a full round trip of what Shift5 is able to do when integrated onto a weapon systems platform, from collecting the raw serial bus data to analyzing all of the positional information as an example in the GPS anomaly case, alert to anomalies both to crews and to ground station such that supporting teams can investigate that and analyze it in real time. The very same example that you saw here today is is on a fleet across multiple aircraft types within the DoD today, and we're also working with them on expanding the use cases to what Josh said, whether that's classes of cybersecurity anomalies, maintenance anomalies, safety critical anomalies, and the like. If there's any interest in talking more about this, we would love to after the demo as well.
Awesome. Thanks, everybody.